Hi everyone and welcome back to Operational Technology Security. Today's module is about risk management and risk assessment. What is risk? Risk is a measure of the extent to which an entity is threatened by a potential circumstance or event. In other words, we're trying to measure how bad the situation can be and what is the probability of this situation occurring. As a motivating example, let's think of car insurance. Every time we drive our car, there's always a chance of being involved in a car crash. And if a car crash happens, then it could be an injury or worst case scenario, death of humans, or it could be just damage to the cars, to the two cars or other property. So there's always the risk of being involved in a car crash, and if you get involved, then maybe paying hospitalization fees or paying for fixing the cars could be something you cannot afford. So to reduce the risk of this happening, of you going bankrupt or not being able to afford the payments, you buy insurance. So you kind of transfer your risk to another entity. So the insurance provider will cover the expenses for you when you get involved in a car crash. But if you're not, then you're just paying that money and it's kind of lost. But in a way, this is a way that you're reducing the risk of this event that can happen. Back to how organizations manage risk. Actually, organizations manage risk every day in meeting their business objectives. There's always a financial risk, something going wrong with the stock market, the stock price go down, then they have to manage that. Equipment failure, personnel safety. If we look at the operational part of an organization, there's always a risk of damage being done to the equipment. There could be, worst case scenario, an explosion. Something, again, can be wrong. Personnel safety can be threatened. So there's always procedures in place to reduce the risk to equipment and humans. And this is an ongoing process, interactive ongoing process of risk management to ensure that things go smoothly in the day-to-day operations. Organizations that use industrial control systems have actually historically managed risk through good practices because of the unique safety requirements. If you have a nuclear plant or a chemical process with dangerous chemicals being processed, then you have to have very good risk management processes to ensure that things go smoothly. And since these organizations already do a good job in managing risk for safety, managing risk for information security can be complementary to that. It can be an added dimension that can use and inform and be informed by the risk management for safety in order to ensure that also information security risk is properly managed. Risk management can be performed at different tiers. So you can see on the slide here on the right-hand side, there's tier 1 to tier 3. And it depends on the visibility and how wide decisions, how widely decisions are affecting the organization. Tier 1 will be the organization level when decisions about, for example, acceptable risk is being made, that we can accept up to medium risk or low risk. Even low risk is not accepted because our organization is part of critical infrastructure, so we have to ensure that even medium risk is assessed. So at this level, decision about our approaches to risk management, what can we accept, what is the budget for it, how much are we willing to spend, what is the vision about risk management, and the approach in the whole organization are being made. And then tier 2 will focus more on the mission and business processes. For example, what is the security architecture we're going to follow for the organization? Because the security architecture is very, very tightly coupled to the business and mission of the organization. Other decisions are the vendors, the suppliers we select, and we ensure that they also have appropriate risk management and cybersecurity processes when we integrate products within the company. And at the end will be the last one, tier 3 information systems, that this is the one we'll focus on and talks about specifically the risk management of the individual components, the risk management of the PLC, of the Windows machines, and other components that are part of our information systems. The three tiers are not disconnected from each other. One informs the other. From organization, the decision you'll make in information systems will be informed by the risk policy and the budget that is defined at the tiers above. Similarly, when you have your risk you do risk management in your equipment or on the software level, you have to also inform back that and say, look, given the budget we have, there's no way we can reduce the risk to the levels that have been defined by the organization. So the tiers are not disconnected. Even though we'll focus on tier 3 for the rest of the presentation, still we have to think about all the tiers and how each one affects the other. So risk management is an iterative process and has 4 different components that we'll discuss in this slide, and then we'll further elaborate on in the next few slides. It starts with framing. So the frame process, the frame component creates the framework for risk decisions. This is our risk tolerance, safety, security, availability, and physical operating environment. We try to understand what is the framework we'll be operating on. If we are, for example, power grid, then there's the risk tolerance will be much lower. We cannot afford even, for example, low risks, because if something goes wrong in our organization, this will have an impact to a whole country. But if we're a small company that does creates copies of printer services or other similar things, then if something goes wrong in our organization, it won't be that bad for other entities or for the nation or for the city or for human injuries or human losses. So this is where we try to understand how we affect others, how we are affected by others, and how much we can actually tolerate in terms of risk. So that's the framing part. So once we frame and we have the guidelines, then we follow with the assessment part. So risk assessment is the process of identifying threats and vulnerabilities and also assigning likelihood of the threats occurring. Also identifies effect on the physical process, dependent systems, and physical environment and safety. So risk assessment is a major component of risk management, and actually the second part of this module will focus on risk assessment. After we assess risk and we come up with a list of possible threats we may have, we decide on how to respond to the different risks. So there we make decisions about all the possible threats we identify in the risk assessment, and we make decisions about how to address each individual component. We can choose to accept the risk. So we do nothing, we say, look, there's this low risk of this happening, I just do nothing about it. We try to avoid or mitigate the risk. There we implement, for example, if it's a security risk, we implement security controls, we add a firewall, we add a new intrusion detection system to mitigate the threat, in an example of man-in-the-middle attack in our networks. We can share or transfer the risk. Buying insurance is an example of risk transfer, that if something goes very wrong, we don't fully cover the financial damage associated with that, but we buy insurance to reduce the risk, to reduce our exposure to that specific risk. So that's the response part. And for the monitoring part, the last component is implementing all the policies we discuss. And whenever there's a change in environment, we need to reinitiate the either the assessment or the whole risk management process. So monitoring is understanding the effectiveness of risk management and restarting or redoing some of the components whenever there's a need. So let's see each one of them in detail and in the context of operation technology. So the framework, the framing part I described in detail before. It describes the environment in which the decisions are made. Again, a cybersecurity risk in the power grid it will be different than a cybersecurity risk in a company that just copies. It's a copier company. And again, the purpose of the framing component is to produce a holistic strategy on how the organization will manage and address risk. What are acceptable responses? What is the budget for it? Making explicit and transparent what are the risk perceptions the organization uses. With regards to ICS specific guidelines, what is very important to be included in the framing component is that health and safety are major considerations when we talk about decision. Even if there is a low risk of something, if that risk is associated with health and safety of personnel, then it has a very different decision-making process compared to something that's low risk and only affects, for example, data loss, a privacy breach. So for ICS specifically, whatever is on health and safety will have different gravity when we're considering response to that risk. Second is ICS availability. In case this ICS is part of critical infrastructure, water or power, then we have to ensure that even a low risk of having unavailability, of having some disruption in operation is not acceptable. So in the framing part, availability is major, and we need to address all possible risks that affect the availability of the ICS. And number three, the physical operating environment is another part of risk framing, where we have to also consider the physical operating environment in case there's a requirement for precise temperature. This is something we need to understand in this part of the risk management and add it when we discuss the responses to that risk. Moving on to assessment, assessing risk is one of the most major components, and the purpose of risk assessment is to identify threats to the organizations, identify the vulnerabilities that can make the threats materialize. Then, after we know what can happen, we need to also understand how bad this can be, what is the harm that can occur given those vulnerabilities, and the likelihood that the harm will occur. So at the end of risk assessment, you have a list of things that can go wrong. What is the effect of that individual risk, and what is the likelihood of this risk occurring? And this is what will be given to the next component for responding to that risk. Specifically for ICS, because ICS is many times is part of critical infrastructure, then the governments and the states have to be involved in the risk assessment process. Because if something goes wrong in power grid, it will affect water systems and vice versa. Also because critical infrastructure is part of a nation, then it's also to the nation's benefit of ensuring that these companies that are associated with critical infrastructure are doing an appropriate risk assessment, and knowledge can transfer from one company to another through government entities. For example, ICS-CERT is an organization that is trying to give generic guidelines to companies that are part of critical infrastructure of industrial control systems and ensure that they all follow similar guidelines, and the knowledge of what can go wrong in one can be transferred to the others as well. But during risk assessment, actually, because the ICS include both physical and digital effects, we need to incorporate those into our risk assessment. So in more detail, first is safety. So a safety assessment will be concerned primarily with the physical world, while information risk assessment is actually looking at the digital world. In an ICS, however, those two are actually intertwined. If something goes wrong in the digital world, this can affect the safety as well. So whenever we do risk assessment for ICS, we have to make sure that the personnel charged with safety assessments are part of also the information security risk assessment. Second is the understanding of potential physical impacts of an ICS incident. If something goes wrong in an ICS, then there is a potential of physical damage. And we need to understand exactly what this means. We need to understand first how an incident can manipulate operation of sensor and actuators, because actuators are actually affecting the physical environment, and sensors also because they affect the control logic that affects the actuators has to also be included in the understanding process. Second is understanding redundancy. Because of safety, there's very often redundant controls. This is another thing we need to understand in the ICS risk assessment, and to include in the risk assessment what are the controls and how a physical incident can emerge based on these conditions. So the condition is, given redundancy, given redundant controls, can we still have a severe effect of the cyber to the physical world? Third is an understanding of physical disruption of the ICS process. So if something goes wrong in one part of a process or within an entity, let's say the power grid, this will cause cascading impacts in other processes within the organization or externally as well. So whenever we're trying to understand the risk assessment process, we need to understand also the external processes, like if we rely on constant power, for example, what if power goes off, if we don't have a supply of power? And if same thing with, for example, water. But even within the process, in the example of desalination we gave in previous lectures, if something goes wrong in the beginning or where we bring the seawater, how can this affect the part where the brine is separated from water suitable for consumption? So we need to understand the physical disruption of a part of a process, how it can affect other parts within the physical process itself or within outside of the outside world. Another thing that's very important to understand during risk assessment is the non-digital aspects. Actually, whenever we talk about physical processes, we do have non-digital control mechanisms such as analog controls, analog sensors, or alarms, or other things that are not purely digital. And whenever we talk about non-digital controls, there are other considerations. For example, they need more time to come up with a proper measurement of a physical quantity, and the accuracy and reliability may not be the same as a digital control system. And this is not to say that it could be worse. It can actually be better, and we may rely maybe on purely analog readings because our digital ones could be compromised, and we'll have to rely on the analog ones to understand what's happening and get good visibility within the process. Examples of non-digital aspects of ICS are analog displays or alarms, so where we measure physical system with analog display. There's manual control mechanism where it provides operators the ability to manually control something like an actuator without relying on the digital control systems. And this, for example, this is how the Ukraine power grid attack ended, where the operator switched from automation to automated to manual operation, and they had manual control over the circuit breakers, over the substations, and they managed to restore power by reverting to that fallback mechanism. And there are also analog control systems where non-digital analog sensors are used, and this is, for example, regulators, governors, electromechanical relays, and this can be used either in conjunction with digital systems, or actually you can build the system with analog controls if that's more suitable for the exact process you have. So to conclude that, and the reason I'm saying that is because the non-digital aspects are difficult to include in risk assessment when we only look at the digital world and the information risk management, but we have to, because they can help us a lot with responding to risk. And we also need to include the impact of safety systems. And safety systems, again, are deployed for safety and are primarily there not to address security, but to address if something goes wrong because of a natural effect, there's an earthquake, or there's some disruption in the power. Safety ensures that there's some appropriate degradation of the operation of the process, graceful degradation, and things won't go, you won't have damage to equipment or human injury. So because safety systems are already in place, we have to understand the impact of them and evaluate them, evaluate the impact of security controls on the safety mechanism first, and second, see also how the safety system themselves can be compromised. And this is exactly what Triton attack did in the petrochemical facility, where you had the attackers actually managed to have a backdoor in the safety systems, so whenever maybe in the future they plan to attack the actual process, they would disable the safety system, so those systems could not respond to something go wrong in the actual physical process. All right, so let's go back to the risk management process. We framed the environment and we assessed the risk. Now we have to respond to the risk. To respond to the risk, you have different ways you can address that risk. You can accept it, avoid it, mitigate, share, and transfer, or you can combine any of these options. And in a way, responding to the risk, it has to be done in a response to the budget you have. You cannot possibly mitigate all the risks. You have to see your budget, you have to see the risks you have, and try to balance the two. And given that the risk is a function of both likelihood and impact, you have to think that, it should be clear that what you should be addressing first is the ones that are more likely to happen and will have the largest, the biggest impact in the organization. So that will be something on this side, like on the top right of the graph. But this is in the framing part of the risk management process. You also create your risk tolerance. So you say my risk tolerance is this, so I'm mostly concerned with likely to happen at any impact, or the most impactful but any likelihood of happening. Or you can be at this curve. You can say, okay, I'm okay with impactful events that are not very likely to happen, and I'm okay with very likely to happen, non-very impactful events. So your line could be here. So you're creating your risk tolerance threshold here in the framing, and then the risk assessment will give you the individual risk you need to address, and the responding, you choose to move things from what is ever outside your tolerance within the tolerance framework you have. So you have to address those unique risks you identified in assessment and ensure that at the end, the final risk you have meets your risk tolerance within the risk budget you have. So that's the response part of risk management. And for ICS, sometimes you're not alone when you have to decide on your risk response. Again, if you're part of critical infrastructure, you cannot easily, regulations don't allow you to say, I accept a medium risk of my power grid going down. The nation won't let you do that. The regulations are for it. So you have constraints coming from other entities, coming from the government, and regulatory compliance. Last part is monitoring. As we said before, organization risk management is not a one-time effort. It has to be done continuously in the interactive process. You have to see whether you're actually implementing properly the risk management strategies you have indicated. You have to monitor whether there are severe changes in the environment, that you have to redo your math, you have to redo your calculation because, for example, there's a new vulnerability that was discovered in a product that you're using in your organization. So this is changing your risk because now the vulnerability can have a severe impact in the organization. So you need to redo the assessment and redo the response part of these of risk management. And you have to also be monitoring continuously whether your risk reduction activities are appropriate. When you have your patching mechanism, does it actually properly reduce the risk? Your cyber insurance, any mechanism you have selected for risk reduction is actually working as it should and properly reduces the risk. So to conclude this component, we saw the risk management has to go through all the tiers from the highest visibility one to the individual components in the information system, and has 4 components: framing, risk assessment, responding to risk, and monitoring the risk. And this is an iterative process that is taking place continuously in a day-to-day basis in an organization.